Good day, folks. Welcome to my YouTube channel. Today we're going to look at the electrochemistry, the second part of it, which is the electrolytic cell. The electrolytic cell, when you look at it, it's one beaker. We call it an electrolytic cell. It has an electrolyte solution here, and it has two electrodes, right? One is a cathode, one is an anode, right? And if you look at this one, it's different from the galvanic. The galvanic, it has no battery. This one, it has a battery. That means it needs a power supply. Now let's go to the definition of an electrolytic cell. An electrolytic cell is a cell in which the electrical energy is converted into chemical. So here it's the electrical energy to chemical, which is an opposite of galvanic. Inside the electrolytic cell, there's a process that occurs that is called electrolysis or electrolysis. The electrolysis is a chemical process in which the electrical energy is converted to chemical energy. Or you can say the use of electrical energy to produce the chemical, right? Now, guys, here, one of the important things here, since it's electrical to chemical, so this type of reaction, guys, it's a non-spontaneous. It's non-spontaneous. So what do we mean by non-spontaneous? That means it requires energy to occur, which is the electrical energy, right? And another thing that is important about the electrolytic cell, it is endothermic. It needs energy, so there's an addition of an energy. It's an endothermic reaction. It's an endothermic reaction, meaning that our delta H is going to be greater than 0. And what do we mean it's a non-spontaneous? That means the EMF is negative, or the EMF or the E cell is lesser than 0, right? Another thing that is important here, guys, in the electrolytic cell, this is just the introduction of the electrolytic cell, and there are types of this electrolysis, or the type of process that occurs there. So here, guys, which is an opposite of what is happening in the galvanic. The positive electrode here is the anode. The anode here is positive, and the anode here, it's when the oxidation takes place, right? And then here we have a negative electrode here. This electrode, we call it's a cathode. In this case, it's a cathode, and the cathode, this is where the reduction takes place, right? And it's very important, guys, very important, that information here. Now, guys, another thing that is important here, the electrons, which is still the same, they coming from an anode to the cathode, right? The electrons, they coming from an anode to the cathode. That means again, in the anode, that's when the oxidation takes place. It remains, it's still the same as the galvanic, right? So in this solution, guys, where we have the electrolyte, it has free moving ion that conducts electricity. So one of the important thing here is that there's an attraction of the anions. The cathode, which is the anode, it attracts the anions, which is the negatives, from the solution. Right? If you look at this, guys, this is an anode, and the anode is positive. It's going to attract the anions there, right? And another thing that is important, The N ions, okay, I'm going to write negative ions, which is they donate electrons to the anode, so guys, once these electrons are attached there, so they donate electrons there, right? There is a donation of electrons, and then those electrons that are donated by the N ions are the ones that are released there, right? And another thing, the electrons moves externally. The electrons move externally towards cathode, So now we are referring to the anode. In the anode, the electrons, they move externally. When we say externally, they move by that wire, right? Okay, let's look at what is happening in the cathode. The cathode, it attracts the positive ions, right? It attracts the positive ion from the solution, as you can see here. So this is negative, right? So it attracts the positive ion, which is the cation ions, from the solution. And what are the positive ions do? The positive ions, what they do, they gain electrons. They gain electrons from cathode, right? So these positive ions, since they are attracted, which is the cation ions, since they are attracted there, so what they do, they get the electrons. Even this is gaining electrons from an anode. So this cation ion is gaining the electrons once it's attracted there, right? And this is where reduction takes place in the cathode. I think that's what is important, guys. Another thing that is important, which is it's the rule that is more of the same, like in the soul bridge, the rule that says N ions move towards the anode, which is, it was the same in the galvanic. And the cation ions, so when I refer to N ions, I refer to the negatives, and the cation ions, I refer to the positive. They move towards the cathode, just like I've mentioned here. The cation ions to the cathode, the N ions to the anode. Guys, those are the basic principle of the electrolytic cell. But in the next video, I'm going to look at the types of the electrolytic Another thing that is important about the electrolytic cell, since I've mentioned that it's a non-spontaneous, in the standard reduction potential table, the galvanic cell, when we're looking at the galvanic cell, the half reaction that is at the top, we will say it was oxidizing, and the one that is below, it's reducing, specifically in table 4b. But also in 4b now, the half reaction that is at the bottom, is what is oxidizing now. So the one that is at the bottom, we read it from right to left. It's undergoing the oxidation. And then the one that is at the top is undergoing the reduction. This is table 4b. So what does it mean? If you look from the tail of these half cells, so if you look from the tail there, if we draw a diagonal line that is going that way, so we get the negative gradient here. The negative gradient, and this negative gradient, it means that this is non-spontaneous, which means the reaction between whatever it is, this reaction and that reaction, that means it's non-spontaneous. That means it needs energy. That means the EMF that you're going to calculate, or you're going to use there it's going to be, the EMF is going to be what? Less than 0, or it's going to be negative.